In this video, we're going to keep looking at absolute value equations. And so in the last video, we talked about how the steps we're going to use, right, are the first we have to isolate the absolute value. And then we're going to split the absolute value. The second step is we're going to, if we have the absolute value of a bunch of stuff being equal to a positive number, we're going to split into the positive. Oops, I usually have been doing the negative case first, the negative and then the positive. So the stuff equals negative the number and stuff equals the number. Or if you have the absolute value of a bunch of stuff being equal to 0, then you just set the stuff equal to 0. Or if you have the absolute value of a bunch of stuff being equal to a negative number, that's when there's no solution. So, the problems we're going to look at, in this case, we're first going to have to isolate that absolute value. So we'll get some practice at that. So, for example, solve the following. 3 times the absolute value of 5x equals 75. So if you notice, here's the absolute value part. Right? I'll circle it here. So here's the absolute value part. So that's the part I want to get all by itself. If you notice, 3 is being multiplied times this absolute value part. So the first thing I'm going to do is I'm going to divide both sides by 3 to get the absolute value all by itself. So we're going to have 5x, 75 divided by 3 is 25. And now that I have the absolute value all alone, I'm going to look and say, okay, is the absolute value part equal to a positive number? Yes, it is. So in that case, I'm going to split this into that negative and positive case. So 5x equals negative 25, 5x equals positive 25. Divide by 5. X equals negative 5, divide by 5, x equals positive 5. Let's try another one. So here I have the absolute value of 8u minus 41 equals 47. So again, here's that absolute value. That's the part I need to get all by itself. To do that, I need to take this 41 here, this minus 41, and move it to the other side. So I'm going to add 41 to both sides. So we end up with the absolute value of 8u is equal to 88. If I look, 88 is a positive number, right? I have the absolute value all by itself. It's equal to a positive number, which means I can split it into that negative and positive case. So you get 8u equals negative 88, 8u equals positive 88. Divide by 8, divide by 8, u equals negative 11, divide by 8, divide by 8, u equals positive 11. So there, again, you get two answers. So we'll try another one. The absolute value of y minus 3, oops, not equals, plus 11 equals 11. So again, here's my absolute value part. I need to get it all by itself. So again, if I circle it, I'm trying to get that pink part all by itself. So I'm going to subtract 11 from both sides. So I end up with the absolute value of y minus 3 equals 0. Remember, when it's equal to 0, that just means that the stuff inside, the y minus 3, has to equal 0. And then I'm going to add 3 to both sides to get y by itself. So y ends up being equal to 3. So in this case, you just get that one answer. And then I have one more example. So negative, the absolute value of x plus 2 plus 14 equals 5. So again, here's that absolute value part. Let's circle it. That's the part I want to get all by itself. So I'm going to subtract 14 from both sides. So we end up with the absolute value of x plus 2. And on this side, it's equal to negative 9. And so now, if I look at this, I have the absolute value all by itself, but it's equal to a negative. So remember, the absolute value of a bunch of stuff can't be equal to a negative. So in this case, it's no solution. So same as we were doing in the last couple sets of these types of problems, but just kind of one step harder in complexity because we have to get that absolute value all by itself first. So remember, that's definitely key. Get the absolute value part all by itself, then figure out what's going on.